So hey guys, good evening. This is me Srijan Upadhyay and I am from the team Bug Relievers. Uh, this is a prototype submission for Indradhanush PCCOE Hackathon 2025. Our problem statement for this hackathon is going to be ocean and marine protection using AI. First of all, let me introduce you with my team. My team name is Bug Relievers. Team members include me, Srijan Upadhyay as the machine and backend developer, Saad Malibhari as front-end development and UI design, Som Salvekar as a key member, and Harsh as a key member because they've been getting the data from the multiple sources as well, which was a very hard task to find the data actually, because the models which we've been creating was a very much dependent on the data which we have got in the data acquisition part only, and Nakshatra for design and documentation. So yeah, this is our team. The tech stack we have used is I might guess that you have already known that Ultralytics, YOLO, Scikit-learn, Python, Pandas, and NumPy. The project which I have created is three mini projects I have created into one. I have integrated that three mini projects into a single project, which is going to be underwater thrash detection, coral bleaching prediction, and water portability classification. So let's see what I have implemented. Now, first of all, there are three streams of project which I have already told you. Real-time detection of the model, environmental prediction, and water assessment quality. Now, what does water portability means? Water portability means the ability of water to be drank or not. Let's say if the water is non-potable, what does it mean? That water is not drinkable. Portability directly equivalently means drinkable or not. Simple. If the water is potable, we can drink it. If the water is not potable, we can't drink it. So now I have the real-time detection, which converts a spot which spots bleached corals and debris of the reefs. Environmental prediction includes predicting bleaching risks from SST, and water assessment quality gets assessment portability from coastal communities. What are the advantages of these projects? The data which we have used was only satellite data and the manual service which we have taken. The capability was very low and real time. So this is a very real time project which can talk about and which can scale up later in the future. Uh, Also, ocean health and research prototypes which are highly scalable, and which provides us AI powered monitoring benefits. So let's say why and how is AI going to power this project. So the speed which we have got in the real-time detection and alerts are going to be providing in the less than 24 hours. This allows for quick response to issues. Right now, if we talk about the global and government issues, what how they are been tackling the reef issue and the maritime issues are 48 to 72 hours, which is about 2 to 3 days. This project and the vision which we have been creating, if we get this, we are going to have two uh, less than 2 days. That means one day, 24 hours. That's it. The cost obviously is going to be very low, because right now they are paying somewhat 5,000 per $5,000 per board survey. Now right now it is from $200 to $500 per site, and then I told you 5,000 for a board survey, which is going to be very low, because it is just about all the data acquisition. We are just going to plant the sensors and we are going to get the data. How we can scale and deploy it to 100 sites in a week, and traditional method would take years, which would achieve the same scale. Right now, first of all, let's talk about the challenges which we have created. Now the challenges which we got was initially the legacy model and the data mismatch, obviously because we had some mask data of Sentinel dash one uh, satellite, which has some UX issues and some latency as well. In that, it was first of all the very huge data, 40 to 50 terabytes of data, which we weren't able to first of all download into our local PCs. But okay, we definitely had them, some part of that. So maybe that data as well we have used, and runtime validation, and then we have built a caching model for system legacy models. Data conversion, we have used pandas as well for the best is it is. Then we have graceful handling, default selection, clear guidance, and solver protection in the next 48 hours. Now, these are the degradation tips, the bleaching event, these are the prediction metrics which are going to talk about. In the YOLO map, scores 0.91 map with pre-trained models, bleaching model accuracy over 100%, the validation test, inference latency, maintains 50 and 150 to 300 millisecond. And these are the model compatibility case handling, fast startup हो गया, modular design and privacy first. Now, let's get into directly into the models working. Yes, so let's create the model. So as you can see, we are into the dashboard, the Streamlit UI we have. Now we get into these sections which we have: classification section, the coral bleaching section, the detection section, and model manager. What is a model manager? As you can see, we have multiple models over here which are trained for trained model, test model, value model, the best model, and there are 10 detection models as well. Why we have used those models? Because while I was training those models, I was having some issues with the compatibility of those models, and also I was having an issue with dealing those models into the real time as well. So I have created multiple models which are already present over here, and I can select into them using this simple UI. If I want to add some models, I can add it over here, or if I have to manually add them using copy paste method, this is what we can do as well. So let's go into the classification first of all section. Water potability classification, as I told you, is the water able to drink or not. So let's check the model. We have to go with the potability model, yes, and then let's predict the model if the model is going to predict. Okay, and let's see, I told you the backend is actually working, it is integrated, it is not a dummy video. Yeah, so the prediction is 0, which means the border is predicted to be non-potable, which means non-drinkable. If we slightly increase the first three values, which is pH, hardness, and solid, the water is predicted to be potable, which means the water can be drinkable as well. And as I can told, as you can see, the backend is still working. And let's go into the second, which is coral bleaching. Now, this is the environmental predictor based on some statistical value which I have trained the model. So I was thinking that I have got a statistical data as well, I've got image data as well. So I said, why don't we integrate both of them into this model? So we have environmental predictor over here with the Kaggle dataset which I had, and then image-based data, image-based detection of coral reef bleaching health as well. So let's get into the first of all the. So now what we can see is prediction model is bleached. The confidence is 99%. As I've told you, this on validation test has got 100% accuracy. Portability, as you can see, not bleached is 0.01 and bleached is 0.9, which means obviously 99% accuracy. And then if you go about, and you can see the validation accuracy as well. Now if you go about, see, we have some incompatible models as well. So this is easier for us to detect the models which are incompatible. Now if we go and browse the images, this is a very bleached reef data set which we have got. And then if we just run the detection, the model is running at the back end as well. Yeah, so we got 84% that this reef is degraded, which means it bleeds. If we download the annotated image, then let's see. Okay, then you can see that we have downloaded the annotated image which can be used for further classifications as well. Okay, so let's go with the detection model finally, which is underwater object detection. I've told you as thrash detection. We have again some incompatible models which I have need to work on as well. Let's get to the browsing section. Let's have this image which I have downloaded. Let's detect the object. So now as you can see, we have plastic bag detected, electronics item, cans detected, plastic bag. Again, if you have to download this annotated image, I can see again we have this annotated image as well. Every single accuracy over here which you can see was more than 98% for each. And then we have, as you have seen, model manager as well. This is the basic readme which we have seen, and the future scopes of this model will be going to be oil spill detection model which we are going to use using the Sentinel-1 model satellite which are going to get. And maybe if we explore that data so much, we are going to get that data as well, and we can integrate another thing which is called oil spill detection data, and then this is the final app.py which we have got. So yeah, this is it, and let's support the reef protection model right now. Thank you.